Hi, welcome to another Algebra 1 video. In this video we're looking at section 3.2, which is Introduction to Linear Functions. In this video we will learn about linear functions, identifying linear functions. We will learn how to graph linear functions. So let's begin with linear functions. In the last video we learned that a function is a relation between a set of inputs and outputs. We also learned that functions can be represented like a two-variable equation, a graph, or a table set. So an example of a two-variable equation could be with the two variables of x and y. We learned that x is the input of the function and the y is the output of the function. Usually when we're talking about functions, we consider the y as our output. So we could say that our two-variable equation could be y equals to 5x. So this is a two-variable equation as we have our output y, which equals 5 times an input. So if I plug in an input in this, I would get an output from that function. And this whole thing is called a function. You can also represent a function by a graph. So if you graph some function like this function, you'd get a steep line that looks something like this. Or you could get a table set, so you could have values of x and y, or the input and the output. So if you plug in 0, you get 0. If you plug in 5, you get 25. If you plug in 1, you get 5. So that's a table set for this function. And these are the many ways in which you can represent a function. But what's a linear function? If you're talking about a function like a graph, then graphically a function would be just a line. So an example of a linear function on a graph could be in these 4 quadrants, and it could be this line. This is a linear function. Or it could be something like this, which comes from this quadrant. Another one could be like this, which is not as steep as this one or this one. So all of these are lines, which mean that all of them are linear functions. So let's do some examples to see how we can identify if something is a linear function or not. So let's look at number 1. I can see that there's a straight line that passes diagonally through these 2 points on the coordinate plane. Since it's a line, we can say that this is a linear function. Now let's look at this function. This does not look like a line. I can see that I have a lot of curvature, so it's a curve, it's not a line. So this is not a linear function. In this case, I have a flat line. It doesn't matter if it's a flat line. It's still a function because it's still a line. So this is a function. But not all flat lines are linear functions. If you have a vertical line, this wouldn't even classify as function because this graph has a lot of outputs for only one input value, which is at this point, and it violates the definition of a function. Another way you can represent a linear function is through a table set. If the table set consists of values that have a constant increase in y for every constant change in x, then it's a linear function. Let's look at some tables and determine if they're a linear function. Let's look at question 1. I can see that in the x values, the numbers are increasing by 1. So it's plus 1 for the inputs. Now let's look at the y values. I can see that in the y set, the values are increasing by 2. So 2 plus 2 gives us 4. Another plus 2 gives us 6. And plus 2 gives us 8. So there's a constant change in the y values for every constant change in the x values. So since it's constant change, this is a linear function. Let's look at number 2. So here I can see that there's a constant change in the x values. There's plus 1 for every input. And here in the y values, there's still a plus 1 input because 5 plus 1 is 6, and 6 plus 1 is 7, and 7 plus 1 is 8. So it's still constant, and therefore this is also a linear function. What about number 3? Well, here I have a constant change for the x's by plus 1, another plus 1. Now let's look at the y value. The y values seem different. So here I have plus 1, but now I have plus 3. That one doesn't match with that plus 3, so it's not constant. Let's look at the next number. Well, now we're adding by 5, so this is not constant. So since there's an inconsistent change in the values for y with respect to x, this is not a linear function. Another way you can represent a linear function is through a two-variable equation. For linear functions, there's a specific format that you usually find when you're graphing linear functions, and that is through the format of y equals mx plus b, where m is the coefficient to the x, or the input value, plus another constant b. So an example of a two-variable equation could be y equals 2x. Another could be y equals to 2x plus 1. So in this case, our m is 2, and the b value is 1. Another example could be y equals to negative 3x minus 1/2. That's also a linear function. However, you may not always find linear functions in that format. You can also find them in other ways that are outside of the format of y equals mx plus b. So you could find a linear function in the format of 2x plus 3x equals to 6. This is the standard form of the linear function. You could also have negative x plus 4 equals to y. That's also a linear function. However, you cannot have the input value in your denominator, or else it's not a linear function. Let's look at question 1, which says that y equals to 2x. In this question, I can see that I have a coefficient of 2, which resembles the m in the y equals to mx plus b, which is this value. And since there's no b, it's still a linear function. Let's look at 2. Y equals to 1 over x plus 2. This is not a linear function because I have x in the denominator. So the 1 is being divided by x, and I can't have that. So this is not a linear function. In number 3, we have y equals to negative 3/5 x plus 1. So we have a fraction that's being multiplied with the x. And then we have the plus 1, which is the b part of the linear function format. So this is still a function. Here we have 2x plus y equals to negative 9. This doesn't look like this format. However, if we subtract 2x from each side of this equation, we get y equals to negative 2x minus 9. So we come back to this format. So originally this was still a linear function. Let's look at number 5. We're given that 5y equals to 3x plus 2. So in this case, it's similar to this format, except we have a coefficient of 5 on the y. Well, if we divide each side by 5, we get y equals to 3 over 5x plus 2 over 5. And that's still a linear function. Now let's graph some linear functions on our own. When you're graphing, some equations use the function notation, which is represented with the f of x. This is simply the y, or the output value of the equation. So if I have y equals to negative 2x plus 4, which is in the y equals mx plus b format, this is the same as saying f of x equals to negative 2x plus 4, because the f of x just means that it's the function of some x value, which equals to negative 2x times that x value plus 4. So when you plug in the x value here, you also plug it into this function, and you find the output value of the function, which is represented with f of x. So a key note to remember is y is equal to f of x. Now let's learn how to graph linear functions using data tables. So we can draw an input-output table for the function y equals to 2x. And we can put our input values for whatever domain we want to list. So let's start with negative 1. So we're going to be graphing the function for x values of negative 1, 0, 1, and 2. Now we can find the y values for these x values by plugging those x values into the function. So when our x value is negative 1, our f of negative 1 would equal 2 times negative 1. And we know that f of negative 1 would equal 2 times negative 1, which gives us negative 2. So our first value, where x is equal to negative 1, would be negative 2. So our coordinate would be negative 1 comma negative 2, which on this graph would be at this point. Now let's do f of 0. So f of 0 would be 2 times our x value of 0. So f of 0 would equal 0, because 2 times 0 is just 0. So our y value in this case would be 0. So 0 comma 0 would be at this point. F of 1 would be 2 times 1. So 2 times 1 would simply give us 2. So our y part of the coordinate would be 2. So 1 comma 2 would be at this point on the graph. Now let's do f of 2, which would equal 2 times 2. So f of 2 would result in 4. And so our y part of the coordinate would be 4. And 2 comma 4 would be at this point. Now that we have plotted all of our points of negative 1 comma negative 2, 0 comma 0, 1 and 2, 2 comma 4, we can connect the dots. So this is what our graphed linear function would look like. In summary, when you're graphing linear functions using this table, for whatever points you're plugging in for x, you have to completely simplify it in the function and then plot the y value for that x value. Once you're done plotting the points on the coordinate plane, you can connect the dots using a line. And this is it for section 3.2. I hope you found this video helpful and you understand the basics of linear functions and how you can identify and graph some linear functions. Leave a like if you found the concepts helpful, and subscribe for more videos in the future. And I'll see you in the next video. Thanks for watching.